Okay, so next example is actually the extension from the previous one, and basically it said that suppose that our demand forecast was done in arrow. It turns out that the actual demand is 120 per week instead of 60 per week. Then what could happen? So let's go back to the previous question a little bit. We know for the previous question, demand will be 60 per week, setup cost will be 12, the product cost will be 2 cents, holding cost will be $0.005, and our optimal order quantity will be 3,870. Okay, so for the problem A here, it said that suppose we want to use the lot size calculated in the previous problem, which is 3,870. What would be the holding cost and the setup cost, the sum of these two? So now we know demand is actually not 60. Let's put the N here to denote the new demand. This is actually 120 per week. In other words, the annual demand will be 6,240 per year. Okay? So now, suppose we order 3,870 units. What would be our cost? So remember the cost formulations. YQ is equal to H times Q divided by 2 plus AD divided by Q plus CD. Okay, and the first term here will be the holding cost, the second term here will be the setup cost, and the third term here will be the product cost. But since the problem description here only mentioned the setup and the holding, let's ignore this for this particular problem for now. And now I know my order quantity will be 3,870. H will be 0.005. My Q here will be 3,870 divided by 2 plus A will be 12. The D here we actually want to use DN, so that will be 6,240 divided by 3,870. Okay, and everything here we got is actually equal to 29.02. So that's a cost that you need to pay when you order 3,870 units. Then in the second questions, it mentioned what would the cost be if we had used the optimal lot size. So remember, if we know we order the optimal order quantity, so Q star instead of Q, then the formulations is actually equal to H divided by 2 times the EOQ formulations, 2 times ADN divided by H plus ADN divided by Q. Again, Q will be 2ADN divided by H. Okay, we want to ignore the third term here as well. And we can simplify this a little bit, just some algebra, and we know this is actually equal to square root of 2ADH. And by plugging all the number, I know this one will be equal to, this is dn, okay, square root of 2 times 12 times 6240 times 0.005. Everything here should be equal to 27.36. Okay, so I know if I don't order the optimal quantity, my cost will be 29.02. When I order the optimal quantity, my cost will be 27.36. What does that mean? For the third question, what's the percentage increase in cost? That is caused by the 100% demand forecast error. So the cost increasing will be from 27 to 29. So I know the percentage of increment will be 29.02 subtract by 27.36 divided by 27.36. This should be equal to about 6.067%. So in other words, I know my demand forecast is not correct and it is off by 100%. However, my cost for the EOQ model will only increase by 6%. And this is consistent with the slide I show you. We know EOQ model is pretty robust.